So what are the angle relationships when I have two parallel lines cut by a transversal? So here are all the list of linear pairs. Just remember those. Two or more angles that form a straight line. We know those, or we should remember that that's supplementary. Those angles are supplementary, which means that they add to 180 degrees. Okay, so look for your straight lines when you've got a diagram, because then you'll know they add to 180. Vertical angles, we should remember, there's the list of them that are in the diagram, and we should remember that vertical angles are congruent. They're the same exact thing, which means that we can set the measures of their angles equal to each other. All right, corresponding angles, and these ones can be a little tricky. Corresponding angles are talking about angles that are in the same location in their group of four. So like angle 1 is in the upper left-hand corner of its top group of four. Angle 5 is in the upper left-hand corner of its group of four. All right, always with corresponding angles, one's going to be on the interior in between the two parallel lines. One's going to be on the exterior outside the two parallel lines. And the relationship between corresponding angles when I have two parallel lines cut by a transversal is that they are also congruent. They are the same exact angles. All right, alternate interior angles. I'm just looking at the interior here. Remember that those are the pairs of interior angles. Their relationship is that they are congruent. They are congruent. All right, what about alternate exterior when I'm dealing with angles on the outside of the two parallel lines? Oops, the angle sign got erased here. All right, those are also congruent. Hopefully you start to see a pattern here. All right, except for I'm going to switch it up here with F, consecutive interior angles. These are also known as same side interior angles. So we don't alternate. All right, these are going to be supplementary. So our angle relationships here, when we have two parallel lines cut by a transversal, we've got supplementary angles and we have congruent angles. One big thing to remember is, especially with congruent angles, look for what type of angle they are. So for example, angle 1 in this diagram, that's an obtuse angle. So any other obtuse angle, it's going to have to be congruent with. All right? If I'm talking about an obtuse and an acute angle together, those would have to be supplementary because they can't be the same if one's obtuse and one's acute. All right, I'll talk about that more when we deal with certain problems, but that's something to remember is power of congruency. Do they look the same? I know we can't assume based off a diagram, but the way two parallel lines cut by a transversal, how that diagram looks or works is if this is an acute angle, then I got vertical angles down there. I have its corresponding angle right here with angle 2, its alternate exterior angle. All of them are acute, so they all have to be congruent. All right, let's deal with some problems. Let's put these relationships into action. So in example 1, the measure of 3 of the numbered angles is 125. Identify those angles and explain why. Then find the measure of angle 6 and explain why. So 125 is right here. Well, I know the measure of angle 1 has to be 125 degrees because of vertical angles. So I know that has to be 125. All right. What about, I know angle 7 has to be 125 degrees because of corresponding angles. Or because it's alternate exterior to angle 1. So this is what I was kind of talking about. All these angles are connected. So it's corresponding to the original 125 degree angle, but it's also alternate exterior to angle 1. And then what other angle has to be 125? Angle 5 has to be 125 degrees. All right, why? Well, it's alternate interior with the original angle. It is corresponding to angle 1, and it's vertical angles with angle 7. All connected. They're all connected. And notice, every single one of those angles is obtuse in our given diagram. All right, then, now that we figured out which angles were all 125, let's find the measure of angle 6. Well, angle 6 is right here. So I know that that needs to be supplementary with the original 125. So I can take 180 minus 125. That's going to give me 55 degrees. So I know the measure of angle 6 has to be 55 degrees because it's same side or consecutive interior with the original 125. I also know it because it's a linear pair with angle 5 and with angle 7. So because angle 5 and angle 7 are both 125, I know angle 6 has to be supplementary to that 125. Okay? Hopefully you see how you can move these angles around with the power of congruency. All right, what about example B? Find the measure of angle 2. So angle 2 is this angle right here. All right, I don't know anything about it, but I do know that I do know two angles, an expression to represent two angles. So what is the relationship between this 4x squared plus 37x minus 78 and with this x squared minus 5x plus 138? Well, those are alternate exterior angles. And I know that alternate exterior angles are congruent. Therefore, I know I can set these two expressions equal to each other. So what I'm going to do now is solve this quadratic. I got to set it equal to 0. So I'm going to move everything from one side over to the other. And what I'm going to be left with, equal to 0, is 3x squared plus 42x minus, what's that going to be, 216 equals 0. Oops, 3x squared, there. All right, now always look for a greatest common factor. I can divide a 3 out of each of those. And when I divide a 3 out of each of those, I'm going to get x squared plus 14x minus 72 equal 0. All right, now I do want to factor this or use the quadratic formula. So I'm looking for two numbers that are going to multiply to negative 72 and add to give me 14. All right, so they got to multiply to give me negative 72, add to give me 14, because the a value here is 1. That's how I know I can use that kind of trick. So, what multiplies to give me 72? Well, I got 1 and 72, 2 and 36, 3 and 24. Is there any way that any of those can combine to give me 14? Not yet. So I got 4. 72 divided by 4 is 18. Well, if I do 18 minus 4, that'll give me positive 14. And if I do 18 times negative 4, that's going to give me negative 72. So that's how I know that this is factored correctly. All right, so because if I check this, the inners and the outers, those combine to give me the middle term, and then the last two terms multiplied together give me negative 72. That's how we know this is good. All right, now I got to solve it though. So I'm going to break each of these off, set each of them equal to 0. So I'm going to get x to equal 4 or x could equal negative 18. So now I got to figure out which one of these do I want. So I got to test them. Got to test them into both of these angles. So I got if x equals 4, then I'm plugging in 4 every time I see an x, and I'm going to test it. All right, so I'm just showing you what I'm actually going to be typing into my calculator. So if I plug in 4, the top angle will equal 134 degrees. And because I set them equal to each other, I know the bottom will also be 134 degrees. All right, so x equals 4 works. That gives me two positive angles. What about if x equals negative 18? Sorry, lost my train of thought. All right, so I'm plugging in negative 18 now to see if I need to include this x value. So I'm just showing you what I'm plugging in my calculator. And if I use my calculator to figure out what this is, you're going to see that these angles are 552 degrees. While that's a possible degree measure, it's positive, it does not make sense in the context of this problem. This angle needs to be between 0 and 180 degrees. So 552, no good. This part is not going to work for us. X equals negative 18 is not going to work for this problem. So x equals 4. So each of the angles is 134. But don't forget, we are trying to find angle 2. Well, angle 2 forms a straight line with this 134. So that's going to be a linear pair. So the measure of angle 2 plus 134 has to be 180. So the measure of angle 2 is going to be 180 minus 134, which is going to be 46 degrees. All right, and that's how you do that one. A lot of different things going on there. Okay, algebra setup. We got to know the angle relationship so we can set up the algebra. We got to solve the algebra correctly. We have to test what we got out for our variables to see which variable value we want. And then we got to use it again. We got to use a different angle relationship to actually solve for the angle we want. All right, we've gone through a lot in this video. In the next video, I'm going to wrap up with this example C because there's a lot to discuss there as well. So make sure you watch the next video to get another similar problem to what you'll have on quizzes and tests.